Frequency, wavelength, and period. You should be familiar with the graphs of y equals sine of x and y equals cosine of x, as well as y equals plus or minus a times the sine of x and y equals plus or minus a times the cosine of x, and how the amplitude affects the shape of the graph. You should also be familiar with transformations of graphs and how to stretch graphs vertically and horizontally. In this lesson, we will stretch the graph horizontally, changing the distance between peaks of the wave, called wavelength or period. We will find the period and frequency from the equation and also from the graph of a wave. We will graph waves given the equation. Recall that a multiplier in front of the sine function will make the graph taller. This stretch factor is called the amplitude. We will now look at how a multiplier to the input variable x will affect the length of the wave. Recall that multiplying the input doesn't make the graph wider, it makes the graph thinner. The graph of y equals the sine of x goes through one complete wave every 2 pi. The length of a wave is called the wavelength or the period. We will use the terms wavelength and period interchangeably. The wavelength can be found by measuring the x distance between the top of one wave and the top of the next. For y equals sine of x, the period is 2 pi. We could also measure the wavelength using consecutive low points. We could also measure the wavelength using the middle points. For y equals the sine of 2x, the wave should be twice as narrow, so that instead of going through a full wave every 2 pi, it goes through a full wave twice as fast, or every pi. The wavelength, or period, is pi. The idea of frequency is more intuitive to physicists. The frequency of a wave is the number of waves that are completed in 1 unit of time, or in this case, 1 unit on the x-axis. If the wavelength is 2 pi, then there is 1 wave every 2 pi, so the frequency is 1 over 2 pi. In this case, b is 2, so that there are 2 waves every 2 pi, or 1 wave every pi, so the frequency is 1 over pi. Notice that when b equals 2, the frequency doubled, and the period is cut in half. For y equals the sine of 4x, the wave should be 4 times as narrow, so that instead of going through a full wave every 2 pi, it goes through a full wave 4 times as fast, or every pi over 2. The wavelength, or period, is pi over 2. In general, the period is 2 pi divided by b. The frequency in this example is 4 over 2 pi. In general, the frequency is b divided by 2 pi. Here are the formulas for period and frequency. To draw a graph of y equals the sine of 5x, we begin with the period, which is 2 pi over 5. We will divide 2 pi over 5 into 4 equal parts, each of which is 2 pi over 20, or pi over 10. I will call these 4 values the quarter markings and denote this spacing with the letter Q. We can then make the 4 quarter markings on the x-axis at pi over 10, 2 pi over 10, 3 pi over 10, and 4 pi over 10. Place points starting at x equals 0 that are in the middle, top, middle, bottom, and middle. Note that the amplitude is 1, and sketch the wave. We can graph a wave where both the amplitude and period have been changed. For y equals negative 2 times the cosine of 3x, we'll first mark the x-axis. The period is 2 pi over 3, which we divide into 4 equal parts of 2 pi over 12, or pi over 6. The amplitude is 2, so we will place marks up to 2 and down to negative 2 on the y-axis. A standard cosine wave goes from the top to the middle to the bottom to the middle to the top. But this cosine wave is flipped top to bottom because of the negative sign. So we will use the pattern bottom, middle, top, middle, bottom. Now let's work backwards. Here's a graph. Let's see if we can find the equation. The graph passes through the origin, which is what a sine wave is supposed to do, but it starts out going down rather than up, so we should begin with a negative sign to flip the graph. It goes up to a height of 3 and down to -3, so the amplitude is 3. The graph completes its first full wave at 4 pi, so the period is 4 pi. Thus, 4 pi is 2 pi over b, making b equal to 1/2. The equation of the graph is y equals -3 times the sine of 1/2 x. Amplitude and period are measured in the same way for cosine waves. Let's see if we can find the equation for this graph. The graph is at its high point when x equals 0. This is how we tell the sine wave from the cosine wave. The sine wave passes through the origin. The cosine wave is at its peak at x equals 0. The wave goes up to 2 and down to -2, so the amplitude is 2. The graph completes a full wave at pi over 3, so pi over 3 is 2 pi over b, making b equals 6. The equation of the graph is y equals 2 times the cosine of 6x. To recap, the period, or wavelength, is the x distance between the tops of two consecutive waves. If you are given the graph, you can measure the period directly. The frequency is the reciprocal of the period. Frequency and period can be found from the equation using the formulas here. To graph a wave from the equation, mark off the y-axis using the amplitude. Find the period using the formula and divide it into 4 equal parts to place the quarter markings. Then place the key points and sketch the graph.